Very good morning, students. In this session, today I'm going to explain about one of the natural phenomena. So, I already told in the previous video, there are mainly two natural phenomena. The first one is already I was explained about a rainbow. Today, let us discuss about another natural phenomena according to your second PUC syllabus, that will be scattering of light. See, the scattering of light is one of the natural phenomena takes place in the atmosphere. To understand what is the definition of scattering of light, see, scattering means change in direction. So the change in direction in the atmosphere takes place here. See how the scattering of light takes place in the atmosphere. See here, this is what the Earth's surface, right? So you know that Earth revolves around the sun. It means sun is during sunset and sunrise, it will be in the horizon position. This is what horizon position. So this is sunrise position, and this one will be the sunset position, and this is almost sun nearly at the overhead position. This is overhead position. Now we know that the earth cover with the atmospheric gas molecules. So up to certain kilometers, earth is having atmospheric gas molecules. Mainly it contains nitrogen, oxygen. So these molecules are present in the atmosphere. Now what happens when the sunlight enters through the atmospheric gas molecules? It can absorb the light. Once the light is absorbed, and so after absorbing, immediately it will be re-emitted. So while absorbing and re-emitting, the direction of the light will be changes. So that's why scattering of light is a natural phenomena in which light is changing their direction due to the presence of atmospheric gas molecules present in the atmosphere, right? So now what happens here, once the light can changes their direction in the atmosphere due to the presence of the gas molecules, that phenomenon of light is called scattering of light. So in physics, the definition of scattering of light states that the absorption and re-emission of sunlight by the atmospheric gas molecules is called scattering of light. See, according to the emitted light, so here absorption is a process and it will be emitted immediately. So depending upon the emission wavelength of light, there are two types of scattering. So in the types of scattering, first one is coherent scattering. Coherent. Co means same. So same means, so whatever the light coming in the atmosphere will be absorbed. So that light is having certain wavelength. So that light is having certain wavelength. So whatever the wavelength observed by the atmosphere, same wavelength should be emitted. So that is such a type of scattering is said to be coherent scattering. So according to the coherent scattering, the light absorbed having same wavelength when it is emitted. So that's why the scattered light and the incident light is having same wavelength, same wavelength, same wavelength. Lambda represents wavelength. The incident and scattered light of same wavelength. So the reason for this coherent scattering is the gas molecules present in the atmosphere, if it is smaller than the wavelength of incident light. See here, smaller than the wavelength means, for example, if I consider VIBGYOR, in VIBGYOR, there are 7 colors. Violet is having a shorter wavelength and red is having a longer wavelength. It is around 4000 angstrom unit to 7800 or almost 8000 angstrom unit. So if the size of the medium particles is smaller than this, if the size of the medium particle is smaller than this size, then there is a scattering called coherent scattering. So example for coherent scattering is Rayleigh scattering. So one of the example for coherent scattering is Rayleigh scattering. I will tell what is the statement of Rayleigh scattering later on. So before that, so let us come to know that. So what is the incoherent scattering? So incoherent, it means opposite to this one. So coherent, so what is the meaning of coherent scattering? The incident wavelength and scattered wavelength are of same, but here it is different. So whatever the wavelength incident is a different wavelength. So incident wavelength and scattered wavelength is are of different, not same. So that's why it is called incoherent scattering. The reason for this is, so whatever the medium particles present or whatever the particles used for scattering whose size is greater than the wavelength of incident light. So whatever the wavelength is incident is greater than the size of the medium particles. So that's why, so it means the wavelength of the light is smaller than the size of the medium particles. Smaller means here it is the medium particles is smaller, here the medium particles is larger when compared with the wavelength of incident light. So wavelength decides the colors, we know that. So it means finally we conclude that there are two types of scattering, coherent scattering and incoherent scattering. Coherent scattering is the scattered wavelength and incident wavelength are of same. Incoherent scattering, the scattered wavelength is different than the incident wavelength. Here the size of the medium particles is smaller than the wavelength of light used, and here the size of the medium particles is larger than the wavelength of light used for the scattering. Here, see, to understand, so example, let us consider the example for incoherent scattering. This is Raman effect. Raman scattering I will consider. Example for incoherent scattering is Raman scattering. See, in the examination, the commonly asked questions is write the difference between types of scattering. So here the first type of scattering, the first difference between coherent and incoherent scattering is, the first difference you can write like this. In coherent scattering, the wavelength of scattered light is same as incident light. In the same point, for incoherent scattering, the wavelength of scattered light is different than the wavelength of incident light. This is the first point. While writing the second point, the size of the medium particles is smaller than the wavelength of light used. Here in the same point, second point, the size of the medium particles is larger than the wavelength of light used. So this is about difference. And example, so Rayleigh scattering is an example for coherent scattering. Here along with Rayleigh scattering, we can write one more example, Tyndall effect. So that will be the example for coherent scattering. So incoherent scattering, example for incoherent scattering is Raman scattering. So it's a very, very important for your examination. Come to the next point. Here, so this is one of the important question, Rayleigh's law of scattering. So very simple statement. So Rayleigh's law of scattering is commonly asked for the examination for 1 mark. State Rayleigh's law of scattering they will ask. So very simple statement as I told. So the intensity, you know about what is intensity. So concentration of light is nothing but intensity. The intensity of scattering, is inversely proportional to 4th power of the wavelength of light used. So here intensity of scattering. So which light will be scattered more? The light will be scattered more having lesser wavelength. It means the inversely proportional to 4th power of wavelength. So the light will be scattered less if they are having shorter wavelength. The light will be scattered more if they are having longer wavelength. That is the meaning of this inversely proportional. Here what happens in VIBGYOR? So in VIBGYOR 4000 angstrom unit is the wavelength for violet color. So here 4000 angstrom unit means compared to this red, 8000 is the wavelength of red light. See, between these two, 4000 to 8000, the remaining color wavelength can varies. Now what happens here? According to Raleigh's law of scattering, it clearly says that intensity of scattering is inversely proportional to fourth power of wavelength. So which is having shorter wavelength? This one, violet. So it means violet color will scatter more intensity than the red color. So on scattering intensity, violet is having a larger scattering intensity than the red color. It means scattering goes on decreases from violet to red. So red is the least scattering intensity compared to violet. So this is about the Raleigh's law of scattering. So with the help of this scattering of light, we can explain these phenomenon exhibit in the atmosphere. You know that commonly everyone can observe the cloud is appears in the atmosphere appears as bluish in color. So the cloud appears in white in color. The sun looks reddish in color. So for all these three, the reason should be of same phenomena called scattering of light. So in the examination, if they ask why the sky will appear bluish in color, if they ask, the direct answer for this one is scattering of light. So due to scattering of light, the sky will appear bluish in color. So how it is possible? Why the sky will appear bluish in color? How it will be help in scattering? How to explain this? So Rayleigh scattering can help to explain this. See here, what happens? So in the atmosphere, when white light enters, so all the white light should be absorbed by the atmospheric gas molecules and it starts re-emitting. So while it is re-emitting, it can changes their direction. So when it changes their direction, according to Raleigh's law of scattering, which is having more intensity, so the light is having shorter wavelength, is having more intensity of scattering. So compared to here in Vibgaya, so violet, indigo, blue, these colors whose intensity is higher in the scattering compared to that longer wavelength colors. See here, which are the longer wavelength colors here? Red, orange, yellow. Now they are least scattered and these shorter wavelength colors are highest scattered. So that's why in the atmosphere we are not seeing violet color but we are seeing blue in color, because so violet is not observable color compared to blue. That's why in the atmosphere we can see blue. The sky will always appear is in blue in color. That is because of Raleigh's law of scattering, or simply we call them as scattering of light. So that is what the reason for that. Next one, cloud appears white. See here. So compared to in the sky, atmospheric gas molecule contains oxygen, nitrogen, different gas molecules whose size is smaller than the wavelength of light used. So when there is a formation of cloud in the atmosphere, so there is a formation of water molecules. The size of the water molecules is almost same as the wavelength of light used. Now what happens here? So all the light will scatter with same wavelength. I mean the intensity of scatter remains same for all the colors. So in the cloud formation. So that's why cloud appears white. Last one, sun looks reddish in color. Obviously everyone can see during dusk and dusk the sun appears reddish. That color specifically called as a crimson red. Crimson, you know that what is crimson? So it is almost equal to brick red, we call them as. So during sunset and sunrise, the sun position is almost near to its horizon. So when the sunlight travels from here to the observer, it can take for long distance. So when it is travels and comes to the atmospheric gas molecules, obviously we know that. So according to Raleigh's law of scattering, the intensity of scattering is more for the shorter wavelength. It means so shorter wavelength colors will scatter and they won't reach to the observer. So only the longer wavelength colors can reach to the observer. Which are the longer wavelength colors here? Red, orange, yellow. So that's why the combination of those colors appears as crimson red. That's why during sunset and sunrise, the sun looks reddish in color, that is mainly because of scattering of light. But one more phenomena you can observe in the atmosphere. See, during afternoon time, when the sun is at overhead position, the size will be little bit smaller. So, but if you are seeing the sun during sunset and sunrise, the size will be very large. So, why the size will be very large? That for that reason we cannot say scattering of light. So, for that reason, the reason for that purpose is called atmospheric refraction. See what happens, and one more phenomena you can observe. Day is longer than night. It means daytime is longer than the night time. So that for that reason also, so why the day is longer than night, if they ask, the answer for that will due to the atmospheric refraction. Actually, whatever the sun we are seeing during sunset and sunrise, that is not actually sun, their refracted image in the atmosphere, because due to the presence of atmospheric gas molecules, there is a refraction produced in the atmosphere. So that's why we are not seeing the actual sun during sunset and sunrise. Their images are seen. So while forming their image, the size will be very large. So when compared the size of the sun during the afternoon time, or when the sun is at the overhead position. So here we can observe mainly, so four phenomena. Bluish color of sun, cloud appears white, and sun looks reddish color. For all these three, the reason should be scattering of light. So especially we call them as Rayleigh's law of scattering. So what is Rayleigh's law of scattering? The intensity of scattering is directly or inversely. It is inversely because it is reciprocal here. The intensity of scattering is inversely proportional to fourth power of the wavelength of light used for this scattering. It means according to this, blue and these shorter wavelength colors will scatter more than the longer wavelength colors. That's why the sky will appear bluish in color, because violet, indigo, blue colors will scattered more when compared with the other colors. That's why if you see the atmosphere, it appears to be blue in color. But if you see the clouds, so when the clouds is seen, but they won't see like bluish color, it appears to be white. The reason for that is the cloud molecules is almost the same as the wavelength of light used. Therefore, all the light can scattered with the same intensity. That's why it appears to be, we cannot differentiate the colors in the cloud because the cloud appears as white. Now, the last one, sun looks reddish in color. Why it looks reddish in color? When the sunlight travels from horizon to the observer, it can enters to the atmospheric gas molecules. So when light travels for longer distance in the atmosphere, so the violet and other colors, shorter wavelength colors, will scattered more, and they won't reach to the observer. They can scattered here itself and they won't reach to observer. Which colors can be reached to the observer? Only the longer wavelength. So longer wavelength can reach to the observer. Longer wavelength means which color we can see? Only red, orange, yellow. So the mixture of that colors appears as crimson red. That's why sun looks reddish during sunset and sunrise. But in the afternoon it won't look like reddish. Right. And one more important thing, the size of the sun is more during dusk and dusk. Dusk means sunrise and dusk means sunset. So reason for that is, the main reason is atmospheric refraction due to the presence of atmospheric gas molecules. And day is longer than night, same reason for that one also. So this is about scattering of light. In the examination, here 1 mark and 2 mark questions should be observed here or asked for the examination. So one of the important question is types of scattering they will ask. Another one is state Rayleigh's law of scattering they will ask. And they will ask this one also, blue, why the sky will appear blue in color, and why the cloud will appear white in color, and why the sun looks. For all these questions, the answer should be due to